All right, now we're going to look at section 9.2, and we're dealing with special right triangles. So the first learning target is we're going to be finding side lengths in those special right triangles, and then we're going to be solving some real-life problems with those special right triangles. This is something you're definitely going to need in your notes and need somewhere where you can find easily because we're going to reference it often, especially this theorem right here. This first theorem is dealing with our 45, 45, 90 triangles, okay? This is one of our special right triangles. So in this 45, 45, 90 triangle, I know the lengths of the legs are the same because the angles are the same, right? We've talked about this in the past. But since I know that the legs are the same, we're going to call them x. And then I know the length of the hypotenuse is x times the square root of 2. This definitely needs to be in your notes right here. And this is a 45, 45, 90 triangle. Okay? This needs to be somewhere we're going to reference often. The biggest thing to note is that the leg is going to be x, and the hypotenuse is x times the square root of 2. So let's look at an example. So here I'm asked to find the value of x and then write your answer in simplest form. So with part A, again I see I have a 45, 45, 90 triangle. I see my leg is 8 and my hypotenuse is the thing that I'm finding. Since I know the length of one leg, I know the length of the other leg is the same. So those are both 8. And I know that using a 45, 45, 90 triangle, the length of my hypotenuse is the leg times the square root of 2. So I can go ahead and substitute the leg length that I know is 8. So I'm going to end up with 8 times the square root of 2. And that's as simple as I can get. I can't simplify this any further. So the value of x, my hypotenuse right here in this first one, is 8 times the square root of 2. So now let's look at B. B, I see that both of these legs are the same length, so I know then it is a 45, 45, 90 triangle because my legs are the same length. And in that 45, 45, 90 triangle, I know that the leg is going to be x, and I know the hypotenuse is going to be x times the square root of 2. So now I can rewrite those and simplify from what I have. Okay? So I know that the hypotenuse equals the leg times the square root of 2. Well, I know the hypotenuse was 5 times the square root of 2. I'm trying to find the length of one of the legs, so I substitute what I know. So now I divide both sides by the square root of 2, and I see over here I have square root of 2 divided by square root of 2, which gives me 1, so that simplifies. So I know that the length of the leg here is 5. So here's my other special right triangle. This is a 30, 60, 90 triangle. And again, this is something that absolutely must be in your notes for a 30, 60, 90 triangle. Okay? We're going to reference this often. So I know here that the shortest leg is going to be my x. And I know it's the shortest leg because it's across from the smallest angle. Okay? So you'll see it's across from the 30 degrees is we're going to call x. The hypotenuse is going to be that 2x. We're going to multiply the short leg times 2 to get the hypotenuse. And the long leg, I take the short leg times the square root of 3. So this needs to be in your notes. You need to reference this often. Okay, so now here we go. We're going to find the values of x and y and then write our answer in simplest form. So I notice here I have a right triangle and I have a 30, 60, 90 triangle. Okay, so now I'm dealing with, and I'm given the long leg, right, because that's the thing that's across from the 60 degrees, and I have to find the short leg and the hypotenuse. So first I want to find the value of x. So I know that the longer leg equals the shorter leg times the square root of 3. This we saw in that last slide. So now I plug in what I know. So I've got my longer leg, which is 9, my shorter leg, which is x, times the square root of 3. So now I divide each side by the square root of 3. So here you might think, oh, I'm done, but we're not quite done yet. We want to simplify, and we don't like having radicals in the denominator, so we have to get rid of that. This is called rationalizing. So I take the square root of 3 and I multiply this entire side by square root of 3 over square root of 3. And we know that square root of 3 divided by square root of 3 is 1, so mathematically I'm not really doing anything. Okay? So now I can simplify. So now in the numerator I have 9 times the square root of 3. And in the denominator, I know that if I have the square root of 3 times the square root of 3, I have 3. So that's kind of simplified there. So now I see I have a whole number, I have an integer, and I've got an integer there. So now I can simplify again because 9 divided by 3 is 3. So my x, or my shorter leg, is 3 times the square root of 3. So now using that information, now I can find my y value. and my y is the hypotenuse. So I can use that, and I know that the hypotenuse is the shorter leg times 2. So now I plug in what I know. I'm looking for the hypotenuse. I found my shorter leg is 3 times the square root of 3, multiplied it by 2. Well, 3 times 2 is 6 times the square root of 3. So my y, or my hypotenuse, is 6 times the square root of 3. So here is your monitoring progress. I want you to try a couple of these and see how well you can do. So now here's our real-world example, that second learning target. So the road sign is shaped like an equilateral triangle, and I know that equilateral triangles have the same measure on all sides and their angles are all the same. So estimate the area of the sign by finding the area of the equilateral triangle. So here's what I have to do. First I have to find the height of this triangle, because I can't find the area of a triangle without the height. So in order to do that, I just divide it in half. Right? So again, I see that this is a 30, 60, 90 triangle. And I know that because I know in an equilateral triangle, all angles are 60 degrees. So if I cut this one in half, that becomes 30 degrees. So now here's just a drawing of what I now have. So the longer leg is h, right? Because it's across from my 60. The hypotenuse is 36. And the shorter leg is going to be 18 because I just cut that side in half and I cut this angle in half. So now I can find the length of the longer leg, right? So I use my 30, 60, 90 triangles, and I know that the longer leg is the shorter leg times the square root of 3, which gives me 18 times the square root of 3. So now that I have the base of the triangle and I have the height of the triangle, I can go ahead and find the area. So I know that to find the area of a triangle, I have 1/2 times base times height. So I go ahead and plug in what I know. So my base was 36, my height was 18 times the square root of 3. So now I go ahead and I use a calculator to solve, and I find that my area is about 561 square inches. And first I had to cut my triangle in half, and I knew I could because I know some information about 30, 60, 90 triangles, which allowed me to find this height of the triangle. Okay, so here's our next example. So a tipping platform is a ramp used to unload trucks. How high is the end of an 80-foot ramp when the tipping angle is 30 degrees and then 45 degrees? So here we've been given the triangle. Here's my tipping angle, and I want to find the height of the ramp here. So first, again, if you're not given this triangle, you always want to draw it and see what it looks like and label the things that you know. So when my tipping angle is 30 degrees, the height of the ramp is the shorter leg, right? Because now it's across from my 30 degrees. So let's go ahead and just label that. So if this is 30 degrees in there, then this is my short leg, right? Because it's across from my 30-degree angle. So I know the length of the hypotenuse is 80 feet, and I was told that in my problem. So now I can use my information from a 30, 60, 90 triangle and determine what I know. And I know that the hypotenuse is equal to the short leg times 2. So that's where this came into play. Hypotenuse equals short leg times 2. So now I can just simplify and I divide each side, and so I know that my short leg now is 40. So this would be 40 if this angle is 30 degrees. So now let's look at the second part, if it's 45 degrees. So if this is 45 degrees, then I know I'm looking for one of the legs, and my two legs would be the same. Again, my hypotenuse has not changed, so my hypotenuse is 80. So now I can solve what I know. So here's using my 45, 45, 90 triangles. So I know the hypotenuse is equal to the leg times the square root of 2. And again, I'm trying to find that leg, so I substitute what I know, and then I divide each side by 2, but I'm not quite done yet. I want to simplify because I don't like the radicals in the denominator. So I multiply both the numerator and the denominator by the square root of 2. So I end up times the square root of 2 over square root of 2. So this ends up giving me 80 times the square root of 2. The square root of 2 times the square root of 2 gives me 2. So then from there I can simplify because I know 80 is divisible by 2, so I end up with 40 times the square root of 2. And that's just being simplified. So now that I have this, now I can go ahead and use my calculator to find that the leg is approximately 56.6 inches. So that also tells me, right, this is just simplifying my final answer. So when the tipping angle is 30 degrees, the ramp height is 40 feet. When the tipping angle is 45, the ramp is about 56 feet, 7 inches. So all I've done was I used my 30, 60, 90 and my 45, 45, 90 triangles to solve some problems. So here is your last monitoring progress using some of these real world problems and thinking about it. Try it and see how you do. Now we're going to look back at our learning targets. So first we had to find the side lengths in special right triangles. Make sure you have this information in a place where you can easily get to it. And then we solved some real life problems involving those special right triangles. So first we always want to kind of draw our triangle and see what we're looking at and label what we know. And then from there use the information from our special right triangles to solve any missing pieces. So now that we've looked at these, go ahead and try the homework for 9.2.